Hey there, and in today's video what we're going to be looking at is a bunch of table of values where we're going to focus on ones that have multiplication involved. Before we look at anything today, I just want to give you a quick little refresher that we do know how to plot points and we know a little bit about our coordinate plane. Just reviewing point J real quick. If you come over 3 and then down 5, you're at point J right there. So that's the over 3 down 5. And that puts us in quadrant 4 with a Roman numeral. You might remember that we have 4 quadrants, quadrant 1, quadrant 2, quadrant 3, and then quadrant 4. And to get up here in quadrant 1, we go over and up, so positive, positive. We go back and then up. We go back and then down, or we go over and then down. So that's just a quick little refresher. And again, you've got your x-axis here, and you've got a y-axis, and this thing is called an ordered pair. And when we see a lot of ordered pairs listed together in something like this, that is called a table of values, okay? So we're going to be looking at patterns today in these table of values. And in the pattern, if we spot multiplication, we're going to call it a proportional relationship, okay? Now I'll come back up here and fill this in with you guys shortly. Let's kind of dive on in here and look at the table of values just so we can kind of see what I'm talking about, okay? Now for this first one, looking at the ordered pair 1, 2, we have another ordered pair 2, 4. 3, 6 is an ordered pair, and 4, 8 is an ordered pair. Now I want you to ask yourself what you have to do to each of these to get each of these. What do I have to do to 4 to get 8? Okay, I've got two options. I can either think of 4 plus 4, or I could think of 4 times 2. Okay, now only one of these is going to work for everything else in the table of values. Now, do I do 3 plus 4 to get 6, or do I do 3 times 2? Times 2. 2 times 2, 1 times 2. So literally all of these are times 2. So let me erase this real quick. Cool. So what we're saying is take each of these x values, take the x, and multiply it by 2. If I do 4 times 2, I get 8. If I do 3 times 2, I get 6. 2 times 2, and so on. And so each of these y values, I get it by saying 2 times the x. Okay, now let's take a look at the next equation over here, or the next table of values, sorry, next table of values. So I've got 5 times something, 4 times something, 3 times something, 2 times something. If I multiply all of these by 5, then I'm going to get each of these. So again, 4 times 5, if I put a times 5 right here, 4 times 5 gives me the 20. If I did 2 times 5, I get 10. So if I do 5 times each of these x values, I get the y value next to it. And that's what this equation here in blue is saying. All right, for the next one, we've got some negatives, and I don't want the negatives to throw you off. If you take a negative 3, and just multiply it by a 3, you do get negative 9. Okay? If we take negative 2, if I did negative 2, times 3, I will get a negative 6. Okay? So it looks like for each of these, I'm doing times 3, times 3, times 3. And you guys remember that 0 times anything is always going to be 0. So it would work even here. 0 times 3 is still a 0. So for this one, our equation is going to be 3 times each of these x's is how you're going to get each of these y's. Okay? All right, now most of the time a table of values will be kind of this up-down vertical table of values, but sometimes it's horizontal. A lot of times actually in science classes you'll see horizontal table of values. So let's just review what you got to do to the x to get the y if it's horizontal. Now you kind of just think about it like, what do I got to do to this 4 to get down here to 16? 2 to 8. I think most of you can see instantly that it's going to just be times 4 times 4. 0 times 4 is still 0, because 0 times anything is always a 0. And if I did negative 2 times 4, it would be a negative 8. So for this one, we're going to have a 4x. And that's how I got each of the y values. 4 times each of these x's is how I got the y. All right, and then for this last one, this one is actually going to bring me back up here in a second to talk about how when you have division in a table, it's really the same as multiplying by a fraction. So let's take a look at this one here. Do you guys see that this time we actually get smaller, and so it'd be 6 divided by 3, 3 divided by 3. This time we have division. And this is still technically a proportional relationship because if I divide by 3, that is the same thing as multiplying by a 1/3, taking a third of something, okay? So right here, we're just going to say take a third of each x, and that is how we get each of these y's. Now, one other thing I just feel like mentioning because I've used x here for both x and a multiplication sign. This right here, I want to point out that this is me saying x and then y, which is right here, x and then y. So that would be like an ordered pair. If I take this x right here, a third of 3, I get 1. Now, when I was in my table right here, that was me just saying like multiplication, like in elementary school, 4 times 5 gives me 20. I did here that was a multiplication, like a -3 times, and then like a -2 times. So I just wanted to kind of clear that up. I didn't want to confuse anybody that like down here, this is me definitely using the letters X and Y. And then right there, I was just using like old school multiplication. And I think that this is a really good time to kind of just point out that that's why these days, and now that you guys are gearing up for algebra, you'd see -3 and then in parentheses and then times the 3 like this, because we want to get rid of using the x as a multiplication because of units like this where we don't want it to be confusing, okay? But now let's kind of go back up here and let me just kind of clean up these notes a little bit and make sure you guys are okay with filling in the blanks and kind of understanding what it all means now. So anytime you have to multiply the x values by a certain number, so like this is an x value that got multiplied by 2. This is an x value that got multiplied by 2. X value got multiplied by 2, and so on. Anytime you're multiplying to get the y values over here, the relationship is called a proportional relationship. Okay, so if you haven't already filled in these blanks, go ahead and fill in these blanks. And friendly reminder that in the table of values, if you see division, that's totally cool to see division. Just remember for the equation, we're going to use the fraction in front of it. So like if the table of values, if you see divide by 4, divide by 4, divide by 4, we're going to put that you'd have a 1/4 x. That's all I mean. That division, we're going to use the fraction instead. Okay? All right, now it is also really helpful to kind of see some non-examples as you guys are learning about what a proportional relationship is. So here's some about what a proportional relationship is not. Here's some non-examples, all right? Try to look at the pattern in this table. Think about what you have to do to 1 to get 6. That's the same as 2 to get 7, 3 to 8, 4 to 9. All right, now we're not multiplying, obviously, because it's not up here with proportional examples. And you guys might catch here that we're just adding 5, so like 4 plus 5, plus 5, plus 5. So we're going to be looking at these later on. Here we're just showing that you'd be adding 5. And we can write an equation for that table of values. Just take each x and add 5, and you'd get the y. But you can see, again, because we're using addition, which is not multiplying, that's why it's down here as a non-example. All right, so this one's not proportional. Now for this one's a little bit tougher to spot the pattern. I'd be really impressed if you could see the pattern in the table of values. And if you want to pause the video to try to look for it yourself, you can. But here it's either times 8, but I know 0 times 8 is not 6, so it's not times 8. All right, I could try plus 7, but then this is only plus 6. But then this is plus 5. So let me go ahead and start writing this down. If I did -1 plus 5, I'd get a 4. This is plus 6. This was plus 7. So I'm doing plus 6, plus 7. Ooh, maybe the next one would be plus 8. And then right here, if we keep the pattern going, yeah, -2 plus 4. And look at that, 4, 5, 6, 7. So we found a pattern, right? But it's not the same number every single time. So again, this is down here as a non-example. This is really nothing. We're not going to even give this one a name later on in the unit. We're going to give it a name when we add the same number over and over again. We will give this one a name. But here, we're not even going to give that a name. All right, let's look at the third one here. All right, so I could do plus 4, but then this is not, nope, I could do times 2, and then times 3. Oh yeah, and then 6 times 4 would be 24. So this one does involve multiplying. And up here, we said if you have to multiply the x values by the y values, that it's called proportional. But y'all, it's not the same number every time. So it's down here as a non-example. This one, I'm going to type it just so we don't get confused. This one is not proportional. It is not proportional because it's not the same number every single time. It has to be the same thing every time for it to be called a proportional relationship. Again, 4 times 2, 3 times 2, 2 times 2, 1 times 2. It was the same thing every time, so that's proportional. All right, you might have multiplication, but if it's not the same thing every time, y'all, it's not proportional. All right, now I keep saying proportional, and where have we heard this word proportion before? Well, when you don't know something, if you're trying to find an unknown, you can set up a proportion. And right here in my table of values, it's the same one as up here. I'm using something on purpose because I know a lot of you know that this is a 20, and now I'm going to show you why this is a proportional table of values. This right here is something I do not know. I do not know what this thing is. All right? But I know that a 2 matches up with a 10. So for example, a 2 matched up with a 10. This input had an output of 10. Input had an output of 10. So then my input of 4, if I have a 4 here, then its output would be the question that I don't know right there. And then you just simply cross multiply. You get a 40 divided by 2, and we know that this is going to be a 20. Okay? I could also use the 3 and the 15. I could say, hey, 3 had a 15. So then my 4 has what? I could have even used the last one and said, okay, I know my 5 matches up with a 25. And then my y, the thing I didn't know right here, 4, it matched up with y. And again, we're just cross multiplying every time. And when I cross multiply, I get 100. And when I do 100 divided by 5, I still get a 20. So this is a proportional table of values because I can set up a proportion using any of the other answers, any of the other given ratios, if you will, and I can use that given ratio to solve and find my unknown. Now, let's say I put something else right here. Let's say I put a 30 right here. And now I don't know this number on this side. So again, you can use any of them. Let's go back to the 2 and the 10. Let me erase this real quick. I know that I've got a 2 and a 10 in my table. That's a given ratio. This time what I don't know is up here, and it's my x, and I know that it matches down here with a 30. So this time I'm going to get a 60. 2 times 30 is 60, and now I'm going to divide by that 10. And 60 divided by 10 would be a 6. So I can use a proportion to find either one, and sometimes what I don't know is up here, sometimes what I don't know is down here, and that might ring a bell from our proportional unit. Okay? One final thing that I just have to mention, that times 5, here it is right here. Oops, sorry, 2 times 5 gives me the 10. So then 6 times 5 would be the 30. Here's my 3 times 5 is the 15. So then 4 times 5 would give me the 20. And the times 5 is also in every single proportion that we can write off to the side. All right, now let's knock out a few more vocab things, okay? Proportional relationships are always going to be written with an equation like this, where you have y equals something times x, okay? Now this something, the coefficient that you guys have been used to, we call this thing a coefficient, the number in front of the letter. This coefficient is now going to get a new name called slope. And I'm going to continue to talk about this throughout the entire unit. We're going to talk about this thing, the slope, and how it's the rate of change for the table of values. And what I mean by that is that this table, it changed by times 5. Times 5, times 5, times 5. So this equation for that table is a 5x. Friendly reminder that your coefficient, 5, is now going to be called the slope because it's telling me the rate of change in the table of values. All right, now let's flip over And let's just again clear up the different parts of this equation. The m, which is the first thing here, I want to reiterate, this is called a slope. So when you see a number right there, we used to call it a coefficient. And in this unit, we're going to call it a slope. Now, we've been taking a number, an input value, and multiplying it by the slope, and we get an output value, the answer, every time, which is the y, an output value. And these x-y combinations are ordered pairs. Now I know this might seem like a lot, y'all. This is like the easiest vocab in the world. All I'm saying is that this number right here, this is a number that you input into an equation. We're going to input. The answer we get, the output, is the y, which is right here. And we just need to figure out what you multiply it by. What is the slope? So 2 times what gives me 6? So times 3. 1 times 3, 0 times 3 is still 0. And negative 1 times 3 is negative 3. So our proportional equation, let's just go ahead and write that, is 3x. And what we're saying is we've got all these ordered pairs from this equation. If I were to plug in a 2, okay, 2 times 3, my output value would be a 6. When I plugged in a 1, 1 times 3 is 3, so my output value was a 3. When we plug in a 0 into this equation, 0 times 3 is still a 0, so my output value is 0. And for the last one, if I did a negative 1 times 3, negative 1 times 3, my output would be a negative 3. So these are ordered pairs, which can then get plotted on the line. So let's plot the point 2, 6. If I go over 2 and up 6, okay, I've got a point. If I go over 1, up 3, I got a point. 0, 0, the origin is a point. All right, and if I go back 1, down 3, back 1, down 3, I'm right here. And you want to connect. I know I've got my little straight line tool, which makes it easy for me, but just try to connect a straight line the best you can right now. All right, cool, there we go. So we are just graphing right here. We just graphed the line y equals 3x. And later on in the unit, part of the goal is to be able to graph this line using this equation. Okay, but right now we've got a table of values. What we see here is that these ordered pairs, these red points, make up the line for this equation, y equals 3x. And the slope is this 3 right here. Okay, so the coefficient is now the slope, and it's in the spot for m in that equation, y equals mx. All right? Now let's look at another one, the one right below it. This is the one that has division, and I wanted to point out the difference between up top when you do times 3, like this one's times 3, whereas this one's divided by 3. And if we see division in the table, I just wanted to have another example here to show you that it would be a 1/3 x. Okay? So what I'm saying is if I take an input of 6, if I input 6, my x value, and I do 1/3 of 6, my output would be a 2. So my input, 6, gives me an output of 2. And that's what I'm saying up here. An input gives me an output. And when I have the input output, it's now just an ordered pair. All right? If I take 1/3 of 3, so 3 is my input, I take 1/3 of it, my answer is the 1. My input is 0. I take 1/3 of 0, and I still get 0. And for the last one, if I take 1/3 of negative 3, so if I input a negative 3 and take 1/3, my answer, the output, would be a negative 1. So now let's go plot these points, okay? In green, I'm going to go over 6 up 2. I've got a 3, 1, and these are still right here in the table of values. You can use the table of values. The origin is still a point. And then if I go back 3, down 1, back 3, down 1, here we are. And again, let's connect. And we can see this one here is a little flatter than the one we started out with up here. But this is now the line 1/3 x graphed on a coordinate plane. I could keep going. I could plug in more x's. and I could get more y's, which is why I have a line here, or an arrow, and then another arrow. I could plug in a -6 and get a -3 right, or a -2. So we can keep going, which is why we have arrows on our lines. These, again, with the table of values, I could keep going, and you could keep telling me more and more and more, but we're just going to stop. We've just got 4 points plotted, but we'll have the arrows just to indicate that it could keep going. All right? Cool. So all we're focusing on, y'all, is now we're taking like how to plot points, which is something you already know how to do. And we've been plotting the points that were in the table of values, and we're just recognizing how to either multiply or divide to get the relationship. Okay? For this one, our coefficient, since we were dividing, this time we should see a fraction. Okay, we should see a fraction. When you're multiplying by straight up like a whole number, you won't see a fraction there. All right, now I want us to real quick take a look at this graph, and let's look at a key feature of proportional graphs. There's something that both of these lines have in common, and it's that they both go through the origin right here, 0, 0. So the key feature of proportional graphs is that they will always pass through 0, 0. And let's think about why that makes sense mathematically, okay? Proportional graphs, we keep saying this, if it's proportional, we're dealing with multiplication. And anytime you input a 0, okay, anytime you input a 0 and you multiply it by anything, your answer will literally always be 0. So this will always be an answer in the table of values. It doesn't matter what the equation is. Anytime you plug in a 0 and multiply it by any number, I could do a third times 0, I get a 0. I could do 3 times 0, I get a 0. So here's 0, 0. Here is 0, 0. It will pass through the origin. And in fact, if I go back to the other page, here is 0, 0. This was proportional. 0 times 3 is still 0. 0, 0, 0, 0. Now I don't see it here, but 5, 4, 3, 2, 1, 0. 25, 20. I'm just minusing 5 every time. So this would be a 5 if the pattern kept going, and 5 minus 5 is 0. So there is a 0, 0 if we kept the pattern going in this table. And same thing here. Let's keep the pattern going. 4, 3, 2, 1, 0. Minus 2 if we do look at the pattern that way. And right there, it'd be a 0, 0. So 0, 0 is literally the staple of a proportional relationship. Okay, they will always pass through 0, 0. If I were to just give you a new screen real quick and just ask, hey, is this line proportional, the one that I just graphed? You would say no. It's definitely not proportional because that right there is not passing through the origin. Now, if I graph this line and ask if that's proportional, you'll say yup, because it passes through the origin. Is this one proportional? Nope, because it doesn't pass through the origin. Is that one? Yes, because it passes through the origin. All right, cool. And so what we're going to look at real quick is just 4 sample problems together so that you feel comfortable with how you're going to practice on the next page and submit those answers into a Google form. So for each of these right here, you're going to decide if the table of values is proportional or not proportional. And if it is, just circle it. And if it is, we're also going to write the equation underneath the table of values. Okay? All right, so let's take a look at this one. Now, I don't see that 0, 0, but we'll talk about that in a second. I think you guys see like times 3, times 3, times 3, times 3. Okay, so this one is proportional. We're multiplying by 3 every time, so its equation is y equals 3x. All right, what about this guy? So we've got times nothing, really. I can't see 4 times anything. Oh, so plus 10. If I did plus 10, plus 10, 2 plus 10. So this one is a plus 10 situation, but we're not going to circle it because it's not proportional, okay? All right, what about this one? Now, I see the 0, 0. That's already a good sign. All right, if I did 4 times 2, and then did times 2, and then did times 2, so this one's going to be y equals 2x. So yeah, this one's proportional. And let's see, let's go back if I could find the 0, 0 here. If the pattern kept going, boom, 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 that would be a 0 there. And if this pattern kept going, that would be a 0 there. So yeah, definitely checks out that it's proportional. Here's the 0, 0 here. Now let's see if I could do a pattern thing to find 0, 0. Before I even look, let's see if I do, this is looks like -4. This looks like -4. Yeah, if I did -4 here, that'd put me into negatives, so I can't find the 0, 0 there. My little shortcut won't work. But let's go from x to y then. So I could -7, or cut it in half, -5, or cut it in half, -3, or cut it in half. So it looks like we'll just cut them in half. This is divide by 2. 2 divided by 2 gives me 1. 6 divided by 2 gives me 3. And remember, anytime we're dividing by a number, we want to just show the fraction. So take 1/2 of each x. And that's how we get each of these y's. So it looks like, yep, this last one is proportional. This one is proportional. And the equation would be y equals 1/2 x. So that's what you're going to be doing on the next page. You're basically going to be deciding for yourself if the table of values is proportional or not proportional. And see how it says circle your answer? I meant to say circle it like if it is proportional, like what we just did. But you can just choose like proportional or not proportional by writing like either a P or an NP, just whichever you prefer. Like if it's proportional, you can write P, and if it's not, you can write NP. You could circle it if you think it's proportional, and then like cross it out if you think it's not. That's all. It doesn't matter to me. In the Google form, you're just going to choose like, is it proportional or not proportional? Okay. Now, the one I wanted to go over with you guys, because I know I'm going to get a ton of questions about it, is down here, number 13. So if you haven't already flipped to page 6, flip and skip down to number 13 with me real quick. Okay. So for this one, I know the decimals are going to throw a bunch of you off, and I just want you to think about money like quarters. Okay. If you had 1 quarter, you have 25 cents. If you have 2 quarters, you have 50 cents. If you have 3 quarters, you have 75 cents. And if you have 4 quarters, you have $1. So what we are multiplying all of these by is actually 0.25, which is the same thing as a fourth. So for this one, the equation would be to take a fourth of each number, take a fourth of 4, and you get 1. Take a fourth of 3, and that's the 3/4, which is the 0.75 for right here. Okay, so for this one, anytime we're dividing, like divide by 4, 3 divided by 4, 2 divided by 4 is 0.5, 1 divided by 4 is 0.25. So there's the 1/4 x, and yes, this one is definitely proportional. All right. So at this time, you're just going to identify for these other ones if you think it's proportional or not, and you'll fill out a Google form. And that concludes this video. Thank you for watching.